take a look at the top here. We're asked to solve the absolute value of capital X greater than C type inequality. Specifically, we're asked to solve the absolute value of 2x plus 5, closed absolute value, minus 2 is greater than or equal to the number 5. Let's follow our steps for solving this absolute value greater than inequality. Step 1 is to isolate the absolute value. To do that, we're going to move the negative 2 over by adding 2 to both sides. We get the absolute value of 2x plus 5 greater than or equal to 7. Step 2, we're going to eliminate the absolute value bars using the rule for absolute value capital X greater than or equal to C means the X inside is either less than or equal to the negative of C or the union symbol, it's greater than or equal to the positive of C. Let's say this again. The absolute value of capital X being greater than or equal or just greater than C, that means we bust it up into two separate inequalities. One of them has the stuff inside the bars, the absolute value bars, being less than or equal to the negative of C, and then we union that possibility together with the other possibility that the stuff inside the absolute value bars is greater than or equal to C, the positive of C. You see, this way we cover all possible values for the stuff inside of the absolute value bars. So we have to union these two options together. And you really need to be very careful to use this rule whenever you isolate the absolute value bars and you get a greater than inequality. Bust it up into two inequalities with a union symbol. One has the stuff without the bars saying less than or equal to the negative. One has the stuff without the bars being greater than or equal to the positive. Now, how are we going to apply that to this problem? We started with the absolute value of 2x plus 5 minus 2 greater than or equal to 5. But then we moved the negative 2 over and we got the absolute value of 2x plus 5 greater than or equal to 7. So having the absolute value bars isolated, we see we have a greater than symbol. We don't have a less than after the absolute value. We have a greater, which means we have to use the rule in the cloud up there. How do we apply it here? Well, instead of using C, we're going to use the number 7. Okay, so the stuff inside the absolute value bars, 2x plus 5, is less than or equal to the negative of the 7. Got that? And then union that together with the stuff inside the absolute value bars, 2x plus 5, greater than or equal to the positive of 7. Okay, you need to do it this way. You don't want to take a shortcut because a lot of times a shortcut just means nonsense when I'm reading it. It doesn't make any physical sense to me or mathematical sense. And then I have to take so many points off, and I hate doing that because I think you might be on the right track. You're just trying to streamline it. Use the actual statement in the cloud like we did here. Step 3, solve each of these little inequalities and union the answers together with a union symbol. Subtract 5 from both sides. 2x is less than or equal to negative 12. Divide both sides by a positive 2. That means we don't flip the inequality sign. We don't flip it. So we get x is less than or equal to negative 6. On the other side, move the 5 over, subtract it. 2x is greater than or equal to 2. Divide both sides by positive 2. We get x is greater than or equal to 1. Now, what do we do with those two solutions? Well, to make sure that we get all of the answers together in the union, we can stack these solutions on number lines. Take the x less than or equal to negative 6, draw that number line, graph it. Take the x greater than or equal to 1, draw that number line directly below, line up the numbers, graph that one. And now graph the union of the two by remembering that a union represents all elements in set A and set B. So you shade everything smaller than negative 7 with a boxy bracket, including the negative 6. You shade everything to the right of 1 with a boxy bracket, including the 1. Set notation for that graph is curly set bracket, all real numbers x, such that x is less than or equal to negative 6, union together with x greater than or equal to positive 1. For interval notation, just express each of the intervals separately and combine them together with a union symbol. The first shading shows the smallest value is negative infinity with an open interval, bracket, comma, negative 6 with a boxy bracket. Union symbol, boxy bracket 1, all the way up to infinity, open bracket. And then the graphical solution, of course, is exactly what the graph that we have for the x less than or equal to negative 6 union together with x greater than or equal to 1, the split interval. and those represent all the same values. And we are finished. Good job. Good job. Meditate on this one. This one's going to be really important in exams. And I know you're going to be able to handle this.